Gavin. Here's my project for individual assignment. I'm using potentiometer, LED, temperature sensor, DC motor, and servo motor. The idea is that usually for my project was the servo motor usually controls a joystick to change the brightness, but here I wanted to use the servo motor to control the potentiometer and the other way around. And it's usually the potentiometer or joystick controls the servo motor via digital connection, and I wanted to do it physically. So going on to the actual project, which is automatic, we can see here's our temperature sensor, here's the DC motor, servo motor, an LED, and potentiometer is being controlled in there. As you can see, it's connected via just very funnily enough, a screw piece like this, and yeah, and that's what will be turning it around. Lastly, I'd like to note that power was a problem for this project. The Raspberry Pi couldn't handle all the motors, even with the capacitors I was using for safety measures. So I had to use a separate power supply for the Arduino, which was able to help the Raspberry Pi out quite a bit. And here's the Pi there. Okay, okay, that is going on to physics system. Second on to database. First off, we can see here I am on my local host. Here you can see all the data I've been printing here, and I can show you that I've been using MySQL. I type in my password. Yeah, and I'm connected. And use, I think I will be using tempdb. Yeah, now I've changed my temp database. Okay, that's basically all I've done for the database side of things. And I can also read from that. Going on to the edge analytics, we can see that the fan here, I will first run a test in PHP in Python in the code. And here we see the main code here for run fan. And so that is controlled by the Raspberry Pi. Stop that. Whoop. Okay, then going on to the servo motor, I'm going to be showing a test on that via this controller here, just to show it working. And it's just a sweep sensor. And you can see that it changes brightness of the LED or the heat of the heating system. Okay, and so then going on, and so all these things are controlled via calculations and analytics of the temperature and analyzing temperature, and then depending on the temperature, it will actually change. It will make turn the motor on or change the position of where the servo motor is, which then increases or decreases the heat. I have been using a ice block here to keep the temperature sensor cool. So now if I run it, it's running, but it will not actually cool down. It will not turn on. But if I use something hot, like this hot water bottle here, this will heat it up. While we're waiting for that to happen, I will show you the web interface. I've actually made a static IP address here, and I'm accessing it via my Mac. You can see here that's a Mac GUI, and yeah, and also I made a DNS server for the web application, so you can actually use this website and access it. That's the website name. Yep. And here is my website. It is way too many places, but yeah, here's my IoT project and the motors I used, and my idea behind the project. And also here's the table from the database. I use PHP to access this data and put it into the HTML. If I link this up, link this up, then it will run the code. And yeah, now I'm going above time, but I would like to show that the sensor works. So I think I've also shown that the web application connection for the web interface, it is connected to the sensor. And also I'd like to just note here that there's 3 headings: the temperature, the motor position, and whether it's too hot or not. When it's too hot, the motor will go on. And yeah, and we can see here that the sensor is running. Yeah, and if we go here, there's a lot of data points I've made already. We're at 15.5. It will take a minute to, and now we're at 16.21. So it's tracking it live on my website. Then you can come to another time and find it. And we're at -1 position of the motor, and we're 17 degrees. And it's too hot, it's 0, meaning it's false. And it will take another 2 minutes or so, and they will then show the fan and servo motor going on. Unfortunately, I can't plan for this as much, so yeah, I will just have to wait for that. What other things, I guess, have I done? Also, big thing, reading serial data. I've had to read serial data from the Arduino via the Raspberry Pi, and input data from that, and yeah, decode it, and then yeah, and I've made a nice little system of whenever temp is written, then then the next thing that's written to serial to the Raspberry Pi from the Arduino is the actual temp data, and yeah, and let's check if our data goes on. On 17.0. I'm gonna see if I can increase the heat of this by just using my hand over the temperature sensor. Is not ideal, but it will make things faster. I did find that this manual part of the project was quite difficult, and the physical system was hard to work with. I'd like to also note the electrical circuit I used for the DC motor. Oh, here it is. There you go. So there it is. The sensor is now above 20. I can show you that here. Yep, 20.4 and 1, and yeah, we're at 0.816 in the positioning. It's pretty high. Anyway, I think that's everything to show you. I've shown you the physical system, I've shown you the database, I've also shown you the edge computing on the Raspberry Pi via the fan and the servo motor, and also the web interface, which was here. And I hope that's enough, and thanks for your attention.